Hello everyone. Hi Rohit.
Hello.
Hi, Sudha. Good evening.
Hi Mugdha. I think we well, let's start. I believe we can make a start and then let's continue and then we'll see. The first thing that I wanted to share today are some points which is related to data warehousing. I found a useful blog. I'll share this with you. This is mainly related to some interview questions and answers, but this is going to help look at some things that we should be aware. Okay, these are things that we should either be aware or these are things that we are going to use, right? Let's start with the basic thing, which is basically the architecture. Okay, so if we are talking about the architecture that we can have when we are installing a data warehouse, okay, then usually the person who has installed it, right, will either have a two-tier architecture or a three-tier architecture. Now, why should we be bothered about this? Is because depending on the tier, depending on the type of architecture which is used, the way the data is stored or the way the data is, let's say, staged, right? That word is going to make a very big role, or it's going to play a very big role when we are going to look into serious activities, or when we actually do serious activities with SQL or with that, it's a data warehouse. So I'll take some examples so that I can explain what I mean by store and stage, right? So uh, the only reason why we need to know what is a two-tier and what is a three-tier architecture when it comes to a data warehouse is where we need to understand how it is stored or how it is getting loaded. Yes, of course, there is a single tier architecture as well. This is the most simplistic aspect, right? So it's the right. It's like we just have a database. We have some source, like the example which we saw on the last day, right? So we had the OLTP database and we have the OLAP, right? So we have the OLAP DB. This is just a single server, just a single host. I have a single host which has the database installed, and there what we are essentially doing, this is the OLTP. I'm simply taking the data out of this and let's say putting it into here. Maybe I'm doing it in a manual way. I'm actually taking all the CSV files, or maybe I have some kind of a connectivity here over the network and I'm running SQL queries to load the data, which we'll see later on. So a kind of combination of inserts, updates, or maybe I'm manually taking CSV files out of this place and putting it into a location in this place. And hence I'm able to access them using things like, let's say, external tables and so on. Right. So these are things which we are going to look into anyway. So please don't worry. But single tier architecture is where, as you can clearly see, this entire part, the part that is of most use for us, okay, considering both the ETL part, the ETL part which is here, right, and the DB part, right. So the DB part is here. So the database as well as the ETL part is at major risk, because if anything happens, okay, to any of these areas, the entire thing is gone. Why is that the case? Because we have a single point of failure. We just have a single unit, right? If it fails, everything fails, right? So this is something that is rarely used in the industry. So that's why it is clearly mentioned over here. It is rarely used in practice. But what is more used in practice, right? What is more used in practice is either a two-tier or a three-tier architecture. The only difference between these two, right? The only difference between these two is this point, okay? The middle tier, right? So what happens in case of a two-tier architecture is it tries to separate physically available sources from the data warehouse. Architecture may not be expandable, right? But does not also support a large number of end users. So that's the limitation. So what I mean by that is the architecture physically separates the sources from the data warehouse, which means that let's say this is the source. The diagram will look almost, let's say, similar. Okay, almost, let's say, similar to what we just saw earlier. The only difference is going to be, okay, or maybe this is not the right thing to draw over here. Maybe I'm going to have a server which is over here. Okay, so this is also a server. Okay, let's say this is server 1 and this is my server 2. Okay, this is inside my data center or some kind of an infrastructure which I have. So this server has some kind of a connectivity to this server. Okay, and this server also has a connectivity to this server. So I'm going to call this, let's say, I'm going to call this the O1, okay, or the OLTP server, right? So I'm going to call this the OL1, okay. So this host is known as OL1. OL1 is the OLTP server. I want to take the data. So what I've done in this case essentially is I've reduced the risk of single point of failure. So I've created a different server where I'm going to run my extract, transformation, and load related programming. So ETL programming will be run over here. Okay, and then I have another server, which in this case is S2, where I'm going to have my DB installation, which means I need to have proper backups in place, obviously, so that if the DB fails, I can recover, right? So, yes, of course, I need to have the backups in place, no problem. But at least I have ensured that if the database goes down, ETL layer will not go down, or vice versa, right? So, worst case, both of them goes down, like a big power failure or kind of, kind of a very, very worst kind of a thing that has happened to my data center. If that is rare to rare actually, where let's say the entire data center that comprises of both of these things, they have gone down, and hence the entire thing has gone down. But the chances of failures are still there. Okay, so the chances of failures are still there. The only problem, as you can see over here, that we have here is as simple as, let me take a different color now. So let's say I have an end user over here. Okay, so that end user needs to have access to the data. Obviously, let's say I don't have any GUI or something. So this end user basically has some kind of a client software. Okay, I'm going to write this as CS. So he has some form of client software which can talk to the database. Okay, so this user can basically type some commands here, just like SQL commands. Okay, or this client software can be as intuitive as Excel. Okay, I don't know whether you are already aware of this. Excel also has a connector to databases. Okay, Excel can connect to databases using ODBC. Okay, so using ODBC connectivity, Excel can, ODBC is something which we will have a look into if you want, or I can share information about it if you are not already aware. So there are two ways in which database connectivity works. One is known as ODBC, the other is, let's say, JDBC. Right? These are the two most common ways. Now, in case of an Excel, we can directly connect, right, using ODBC to DB. So let's understand this client software, let's say, is an Excel sheet, and the user is able to connect over here. The problem here is, at a certain point in time, if I have only one user, things go well. The moment I have, let's say, 100 users, okay, this is where I am gone. Why am I gone? Because irrespective of what laptop they're using, obviously, the client configuration will be entirely dependent on the laptop or the desktop where they're running it, right? But if I have to scale my server to an unimaginable extent so that I can support 100 users, right? So this is going to be a problem for me now. So this is the biggest, let's say, disadvantage of a two-tier architecture. Two-tier architecture always suffers the loss from multiple, let's say, connections from multiple users at the same point in time, right? This is where, right? This is where, or let's say, this is why we have come into the three-tier architecture proposal, where we have three tiers. Okay, we have a bottom tier, which is basically the DB. This is going to be almost similar, but just an extension of the diagram which we had earlier. Okay, so we had a DB, right? This database may even be scaled. Okay, in many three-tier applications, what happens is this database is also scaled in nature. If you want to know how a database is scaled, I can either pass on some info on you on maybe, or maybe you can look into things like, let's say, MySQL database replication. Okay, this is a very, very commonly used open source, let's say, database, where using replication, you can have primary and secondary copies of the same DB on multiple different hosts. What that means is if your primary has gone down, still have a backup copy. And that backup copy is as real time as you think it can be. So it's like on primary, the data is already written and saved on the disk. The moment it is there on primary, it is synced onto the secondary. It's a kind of a primary secondary concept. And then you have things like, let's say, Oracle real application clusters. So these are just two examples. Okay, there can be multiple such examples. Okay, these are just two examples where we could clearly see that we can have, let's say, clustering when it comes to the bottom layer. So this is my bottom layer, which was there already. Okay, this was there in the two-tier architecture. Also, we had a bottom layer, and we had the top layer. Right now, what the top tier and the middle tier means in this context, in this three-tier architecture is, in a three-tier architecture, let's say this is my source OLTP. Okay, this is my source OLTP house. Okay, this source OLTP doesn't matter to my architecture anymore. Yes, I am actually dependent on it, obviously, because it has the data, right? It has the CSV files or the databases and so on. I need to take that data, I understand. But in this three-tier architecture concept, I'm not going to consider it. Okay, I'm not going to consider source as one of my units. I have now become independent of the source. Why? Because I now have an area which is my front tier. This is like, let's say, a BI tool. Okay, this is a proper BI tool. A proper BI tool will include, let's say, things like, I'm going to use the text box so that I can write it in a better way. So this is going to have softwares like SAP Business Objects. Okay, then it is going to have softwares like Tableau. It's going to have softwares like ClickView. Okay, so these are, let's say, softwares which are used for BI. Then it is going to have softwares like Pentaho. Okay, these are, and there are many more examples. Okay, there are many which are there in the market. So this front end layer, right, this front end layer is now going to have a proper BI, a business intelligence tool, which can help you analyze, which can help you visualize the data and so on and so forth. Okay, so this becomes my front end layer. Now this front end layer is entirely provided by me. What that means is I can also create IT architectures which can govern this front end layer, right? I can create things like some things which IT architects are often very proud of, LB or load balancers, right? What it means that, let's say, I have, let's say, Tableau, and to access my data warehouse, I have, let's say, given you an URL. So it is like my initials, sb.analytics.com. Okay, so sb.analytics.com is a website where you can log in. I have given you access if you are paying me. Okay, I will be charging you for this BI, and then you can access or you can log into that front end. You will get two options there in the front end. Let's say the page is going to look something like this. You get two options. One is to upload or play with the data, so you can do your own, let's say, data management from here. You'll get kind of a form or a page where you can upload and, let's say, download the data. And then on the second tab, on the second screen, you get the interface to Tableau. Okay. Now what I can do is that rather than you hitting this URL directly, what I've done in the backend, okay, what I've done in the backend is I've created a load balancer. Okay, what I mean by load balancer is rather than having one server as front end, now I have, let's say, 5 servers as front end. Okay, the moment my number of users increase, let's say I'm on some cloud solution, right? And by the way, that is something that we are going to start using from today. So please keep your Gmail IDs handy. So we are going to have, let's say, 1, 2, 3, 4, 5, 6, 7 front end hosts, and I have a load balancer in front of this. Okay, let's not go into the depth of how a load balancer works, but very simply, the moment you hit this URL on your Google Chrome, right, just like I have this URL opened over here, the moment I hit the URL sb.analytics.com, the load balancer says, very good, I'm going to use some kind of a technique. Usually the most common technique uses round robin. I'm going to pick any of these hosts randomly and send this request, this connection that has come from, let's say, Mugda's laptop. Okay, she's trying to access this. The moment she clicks on this, or she opens this in the browser, right, it goes to any one of the servers. Right, the next time, or even at the same time, if Rohi is going to try the same URL, The load balancer will say, no, I have already passed one request to server number 4 or server number 5. Okay, I'm not going to pass his request in there. I'm going to do it on, let's say, server number 3. Right? At the same time, if Saransh is going to log in, his request gets redirected to the load balancer. Load balancer says, fine. Okay, Mr. Saransh goes to server number 7. Right? What this means is, using this front end layer and using some very easy techniques like load balancing and so on, without even the users coming to know. So this was Mukta's connection, this was Rohi's connection, this was Saransh's connection. It doesn't matter whether the users are IT professionals or not. They'll not even come to know there is a load balancer in the background, and the load will be distributed, and the number of users can be increased, right? So our limitation of two-tier architecture that we could have had, let's say, kind of, let's say 40 to 50 users, now I can have, let's say, thousands and thousands of users. Okay, now I can talk in terms of thousands. Okay, so this is how I can increase my business, I can increase my operations. As my organization increases, if let's say the solution is for a certain company, right, and we are all are working in that company, and we are kind of a data analyst or data science kind of a company, and we have, let's say, 5,000 employees. The 5,000 employees accessing the front end is actually a task, right? If even if the number is quite small, I mean, we know of companies with lakhs and lakhs of employees, right? Then why are we really bothered about 5,000? 5,000 is not really a small thing. Okay, when it comes to IT architecture, I've seen it myself basis my own experience. It is not really a very small thing. You need good, strong architecture kind of a thing to be in place so that you can handle that load. Okay, but in the current day, because the servers are quite cheap, okay, you can go to any cloud service kind of a provider and you can get your servers up and running quite quickly. Same thing that we are going to do right now, which gives us the privilege that we can have this kind of an infrastructure, right? So what we have done until this point in time, just to cut it short, we have a front end layer which is scalable. We have a back end layer which is scalable, and this scalability, because it is increasing in numbers and not in size. If it would have increased in size, I would have called it horizontal scalability. Because it is increasing in numbers, I'm going to call it vertical scalability, right? So I have a vertical, and of course horizontally I can scale anything, right? But up to a certain point in time. So this has a limitation. This does not have any limitation, right? I can create as many servers, small hosts, rather than creating one big monstrous host, right? So taking care of horizontal and vertical scaling, I have created my front tier, I've created my back tier. Now I need a middle tier, right? Now I need a middle tier. Let me just clear the clutter. Clear point is, okay, Mukta, go ahead.
So I just wanted to know, like, where and how can we use these vertical and horizontal things, scaling? Because uh, you said number, like increase in number would
Hmm.
definitely increase the size, right?
Yeah, yeah.
Uh, or is it not like that?
It is like that, but let me just quickly explain. So
Yeah.
let's say I have a server like this. Okay, this is my front end server. I have only one server. I don't know why, but I have let's say decided I'm not going to do any vertical scaling. I'm going to do horizontal scaling, which means I'm going to increase in the length and breadth. Okay, not in the width, which means that I'm going to increase the CPU of my host. I'm going to increase the RAM of my host. I'm going to increase the disk of my host.
Okay.
Okay,
Correct.
but I'm not going to add more
Hmm.
hosts. But now the problem here is, if you go by the architecture, you take Intel, AMD, anything, you go by the hardware architecture provided by any company, there is a limitation to the motherboard. So the motherboard which is
Right.
attached to the
Right.
host can support up to n number of CPU, right? X GB of RAM, okay, Y TBs of hard drive, and so on. So once that is exhausted, you are gone. That host cannot expand beyond
Mhm.
it. Right now, what is the advantage of replacing this with a vertical scaling is that I'm going to have, let's say, 20 servers. I'm not going to draw it. This is just an example. Okay. So
Mhm.
server 1 to server 20, rather than having a server with, let's say, 200 core CPU, I'm going to have 20 servers, each with 10 core CPU, each with 2 GB of RAM. Now I have 20 multiplied by 2, 400 GB of RAM, right? 400 GB may not have been possible over here.
Yes. Understood.
Uh,
Okay.
uh, Oh, sorry, 20 multiplied by 20. Let's say in each and every
20.
host, I have, let's say, 20 GB of RAM.
Mhm.
So in this case, 400 GB would not have been possible, but using small servers, but more in number, I'm able to vertically
Mhm.
scale. Now I'm increasing in the depth, right, in the width,
Okay,
right?
got
So
it.
it is actually going to depend. Now to answer your question, it is going to depend. If you have this
Okay.
kind of a requirement where this will work, then please go ahead with it. I have myself done architectures like this and it has worked. Why it has worked? I had only 10
Okay.
users, right? It has worked, right? It is still actually working into production. But then when I have, let's say,
Mhm.
thousands and thousands of users, I'll go to this.
Okay, got it.
Okay. Now, let's just clear this. What I was saying, let me change the color of the pen. So, what I was saying was front end layer, just to clear the confusion. I now have a front layer. I now have a back layer. Back layer is what? The database, right? Or the bottom layer. And I have a top tier. Okay. So, the bottom tier is this. I have a top tier, which is this. Now, I'm going to have a middle tier. Middle tier is just what we have seen in the two tier architecture. I just have a server. And in that server, I have some softwares. I'm going to write the name of some of the softwares, which is actually going to provide me the backbone for the front end as well as the backbone for the back end, right? So what I mean by that is, I said that when you are going to log into sb.analytics.com, you get an interface to play around with, let's say, Tableau, or you get an interface to upload and download your own file. So that is powered by some kind of a file transfer software. So file transfer software can be installed over here. Then I can have another host. Let's say in host one, I have, let's say, file transfer software. In host two, uh, I can have the Tableau server installed or the Tableau software installed. Maybe I'm going to cluster it. I'm going to have hosts 2, 3, 4, and 5, where I'm going to have, let's say, Tableau installed, right? I'm going to have some shared disks, right? Now, the question is, why, as a data scientist, should I be aware of this? Is because I need to know when my system can scale and when my system can fail, right? Because if I don't know how my system is architected, then I'm going to do things which can easily break my system, right? If I have to put my models into production, right? If I have to uh, create the solutions which my users are going to use day and day, night and night, and I don't know, and I should not be knowing, I should not be guessing the number of users who are there today, who will be there, let's say, tomorrow. I don't want to know. The solution that you want to put into production should be tangible in the sense it works today. It should work at least x number of period of time, because then only you have a cost efficient kind of a delivery, right? But to have that in place, you need to know how the architecture works. Okay, that is the only reason why you need to know the architecture. There is no other reason. Okay, you are not going to work as an architect. You will have roles in a data science team where you will find architects, right? But as a core, let's say, data scientist or machine learning engineer, the role or the need of why you need to know all of this is because then you know what you are capable of doing, how much you can stretch your hands, okay, how much you are not supposed to do, how much you should be conservative, right? So let's say you have a cluster which is like a single tier architecture. You already know you have 5 colleagues working as machine learning engineers. I don't think that's the right time to pull, let's say, 100 GB of data per person. Okay, I would actually rather, in that case, if you know that it was a single tier architecture, you would have done it in a different way. Maybe you have collected the data for the next 10 days. Each day you are going to extract only 10 GB of data, or your sample size will no longer be more than 2 GB. But what forces you to decide that your sample size should be 2 GB? What forces you to limit yourself that, okay, fine, I may have 100 GB data in the data warehouse. It is ready for me to do data science. It is ready for me to do data analysis. I'm going to pick up a sample. I'm going to create a sample whose size is no more than 1 GB, but it is a representation of the population, right? That's the kind of constraint that you can create around yourself, so that you fire a query and the database doesn't go down. Because if it goes down, it's an impact for you as well as your team as well as your company, right? So that's the reason why we needed to know this. I hope it was clear. I'll share this link as well with you. Okay. And then we can read about the rest of the things over here as well. But this was the only most important thing which I thought of sharing with you before going into the next layer. Now, the next layer that we have to look into is the basics of SQL, right? So before we look into the basics of SQL, what we need to do is we need to install, okay, We need to install a database. Okay, now to install a database, I can use my desktop itself. That's not a scalable kind of a solution. Okay, that is not a scalable solution because I will be limited by the hardware. I will be limited by the architecture. I am using a Windows OS, so I can only use the databases where or which runs onto Windows and so on. There's a very easy way of handling this kind of a situation, and the way is to go to cloud, right? And the most, I will not say easy, it is not really easy, but the one cloud service which is really easy in terms of, let's say, the time to market that it takes for you to start with that environment is AWS, right? So AWS becomes, let's say, one of the most easy things or one of the most easy cloud providers where we can start. You can start off within no point in time. You don't need to know much about AWS in depth, and you can start. And then you can try to do things, changes, and so on as you learn, right? As a data scientist, you will need to know cloud. Okay, it's not a permanent thing. I mean, I'm not saying that it is, let's say, a mandate. In any organization, hardly 15% of the infrastructure goes to cloud because still there is a dilemma in the market that cloud means something which is there on the cloud and people have access there because it is always raining. That's not the case. Okay, cloud is basically a data center that's not owned by you. Okay, somebody has owned the data center. The data center is there with, let's say, AWS. In this case, AWS is Amazon Web Services, right? So the data center is owned by them. Hardware, network, and maintenance and all these things are with them. You're simply a user. You are using the platform as a service, right? You are using their infrastructure as a service. You're using the softwares which they're providing, part of their cloud, as a service, right? That's all you're doing, which means you don't have to maintain. You don't have to maintain infrastructure. Maintaining that three layers that we have talked about, right? Front end, middle layer, and the back layer. You need a lot of servers. The servers, if they're going to run, let's say 24/7, the CPU is going to get heated. You need fans, right? You need a coolant system which should be there inside the data center. You need a cabling system which should be reliable. You need disks which will need replacements because disks are the things which gets tired or which gets disturbed very often. Okay, from time to time we'll see the max number of failures or faults that happens in a hardware system, whether you're using a personal laptop or whether you're using the most high-end, it's a data center, are the failures with disks. So you need a lot of people there. You need a lot of maintenance. You need a strategy. You need a project manager. So you need a lot of things to run your infrastructure. What if I tell you, I already have that in my farmhouse, and I'm actually calling that, let's say, SB Web Services, and you can use that. You just have to pay me as much as you use. So let's say we used for 1 hour, I'm going to charge you 1 rupee per hour. Okay, you can create a server, you can do whatever you want to do, and for 1 hour I'm going to charge you 1 rupee or maybe 10 rupee for that server, for the smallest size of the server. The moment you increase the size of the server in terms of more CPU, more RAM, and more disk, I'm going to increase the rate, right? So the smallest server will be like 2 GB RAM and 1 core CPU and so on. It's going to cost you 10 rupees per month. The moment you go to, let's say, 200 core CPU, I'm going to charge you 2000, 3000 rupees per month, right? You don't have to manage infra. All you need to do, I'm going to provide you with free training. Okay, don't worry. You want advanced things, you need to contact our training center. You have to pay there, and you can take the training. This is exactly what AWS does, exactly what, let's say, Google Cloud does, exactly what Microsoft Azure does. But out of these three, which are the market leaders, clearly AWS is very easy. Now, before we start from there, we will be setting it up. We have some time now. We can do the setup. I just wanted to know how many of you already have an AWS account. Is there
I
anyone?
have,
Okay,
I have.
okay, okay. Anyone else? No, right? Okay. I will share a document on how to do it, but let's go through it quickly. So let me just do one thing. Yeah. I'll search for AWS on the Google. I come over here. Okay. I'm going to create one account in front of you. Okay. I'm going to create one account in front of you. Although the name is not really going to resonate with the fact that I am using an AWS, because I've used that name in my Google Cloud platform as well. But is it the front page? You can see all the products and things over here. The most important thing is the documentation, but let's not go into that detail right now. Okay, what we need to do, if I already have an account, I'm going to log in from here. Okay, if I don't have an account, I'm going to create an account. Okay, so as simple as it sounds, you can click on this create an account, enter your Gmail ID, you are done. Okay, you can register with your Gmail ID and you are done. Okay, and the most important, the most good thing is this: AWS accounts include 12 months of free tier access. This means there is a layer, okay, there is a set of services otherwise known as free tier, which are like limited set of its services. Let's say you will get virtual machines with one core CPU and only, I don't know, 1 GB of RAM or 2 GB of RAM. If you are going to run those, they are free. Okay, AWS is not going to charge you for the first 12 months. This is how they attract the customer. The moment you are used to it, you will be paying for it. Okay, you want to know which ones are free, you can simply go to this URL, and this URL will have all the services which are always free or 12 months free and trials and so on, right? So you can select things from here. Let's say EC2. Okay, EC stands for elastic computing. So EC2 is the virtual machine environment which you have. Okay, uh, so in a month you can run 750 hours. Okay, this is per month. 750 hours of runtime you can have. So per day you have 24 hours. Okay, multiply that by something if you get 750 hours. So that many hours you can run per month. If it goes more than 750 hours, you will be charged. Right. So when you create a virtual machine, you will come to know how that charging happens. But let's go back. I'll also share this link. Okay, don't worry. Now I am going to enter the things over here. So I'm going to enter this new ID that I've created recently, and I'm going to enter my AWS account name. It is asking me for choose a name of an account. Okay, so I've entered mail ID. Let me choose a name. I'll give my name aws.2020. Okay, and then I'm going to say continue. Okay, now I'm trying to log in. I'm asked whether it is a professional account or a personal account, so I'm just going to give. Okay, so I'm going to give my country, which is India, address. I don't know, Pune. I don't want to give all the address. Okay, and postal code 411047. This is where I stay. So I have just clicked to agree. I think everything is fine. Okay, so that's it. Create account and continue. This should work. Okay, now it is asking for a credit card number. Okay, why is it asking for a credit card number? Is because if let's say you exceed, okay, if you exceed the usage, right, then they will be automatically charging you. So I need to, if you don't provide the number over here, they'll not allow you. Okay, they'll not allow you to create the account. So let me just quickly put this. Let me just stop the sharing. Of course, give me 1 minute. Okay, give me 1 minute. For in the meanwhile, anyone has any questions? Any questions from anyone? By the way, because we are actually recording the session, right? So that's why I have stopped the sharing. But there's something that you need to know is that when we enter the details of the card over here, it's going to deduct a one-time 2 rupee charge. Okay, it's going to deduct a one-time 2 rupee charge. Okay, if you have two-factor authentication enabled for your, let's say, credit card, you will get the OTP on your phone. Okay, so I have already got that. I'm entering it now. Okay, let me just 928 8 3 8 9. Okay, I'm not. This is going to charge you 2 rupees. Okay, that will be given back to you, so don't worry. So it was going to be a one-time charge, and then it is going to be given back to you, so there is no problem in there. Okay, so please don't be under this impression that there will be some issue. So let me just share it back again. That process is done now, so let me just share it back. So I'm going to enter my number, and I'm going to enter the security key. In the next screen, it is asking for this. So I'll enter this security key. It is going to send me an SMS that is going to contain a 4-digit verification code. That verification code has to be entered over here. So I've got a verification code 9578. Let me just verify it. Your identity has been verified. So continue. So what we have done is basically we have entered our rudimentary details. Then we entered our credit card. It got charged for 2 rupees, which will come back in the next month. Then we also entered our, let's say, uh, the phone number so that we can verify the phone number. That's for the support people to contact you if you're going to take any paid plans like this. Okay, so there are two paid plans. Business plan is like from $100 and above per month, and the developer plan is like $29 per month. Okay, now what we are going to select is a free plan. Okay, free plan is where if you are facing any real problems, you won't be able to raise any support tickets. Okay, so you won't be able to raise any support tickets, but 24/7 self-service access will be there. Okay, and then it is going to depend on what free tier things you are trying to use. Okay, so my registration is done. Let me just see. I don't want to do this right now. I just want to sign into the console. So the console is where it's kind of a GUI. It's kind of a web GUI where we can log in into AWS using the credentials that I've entered. Right, so I've entered my mail ID. I'll enter it again over here. Right, and then I'm going to enter my password, the one which I used to register, right? And the moment I do that, I'm already logged on onto the console. Now, we don't have much time as of today to look into the actual installation of the database. Maybe we'll have to stop in a few minutes. So what I would just like to quickly go through is this. First of all, you can see your own personal information over here. You have an account if you're part of any organization and all these things. So you can see that over here. So that information is here. You can also sign out from here. Please don't do that. The second thing, the most important thing, people do this mistake every time the first time they log into AWS. Please change your region. What is this region is? Throughout the world, these are the places where Amazon has their data services. Okay, so they have their data centers all over these places. Okay, which are used or which are given to you part of your free plan. Okay, part of your free plan they are given to you where you can create your hosts. Now obviously we are in India. Which one should I select? I should select Mumbai. So there is a data center which is there in Mumbai. This is closest to me by the distance of the network cables it takes for me to reach, right? So by the distance of the networking, I'll select Mumbai. Please always make sure that you select Mumbai. However, this gives you the advantage that you are nearer to the data center. This also gives you a disadvantage. You are now bound by the tax laws of our country, which means the charges of running a virtual machine might be more than what you may find in the US. Although we are going to be using the free tier, we won't be exceeding 750 hours per month, obviously, right? Because we just have to do a few things there, right? We are going to create a server, we'll do a few things, we are going to delete it, right? I'm also going to show you how to create a reusable components using storages. Okay, so we are going to completely follow a serverless as much as it's a possible kind of a thing. I am going to create hosts, I'm going to delete them as soon as I'm done, even by retaining our data. That's a cool trick that we are going to use, and we have lots of tools which we can make sure we can use and we can do this. Okay, so that's the first thing. The second thing is the service that we are going to be mostly using is EC2. Okay, now what is EC2? EC2 is Elastic Cloud Computing. These are three things, right? Okay, I'm not fully activated. This is good. So by tomorrow we should be able to continue. Good. So EC2 is a short form of elastic cloud computing. Elastic means it is elasticity is there, right? Elasticity means I can scale it up. Okay, I can scale an existing server to leaps and bounds. Okay, if you look at AWS EC2, Okay, maybe we'll have to close the session now because we are overrunning the time. But if you look at the kind of, let's say, the instance types that we have, right? I'll go to instance types directly. These are the types of instance that I can have. Okay, if you look at, let's say, I don't know, accelerated, let's say, computing. Okay, you look at how many number of CPUs I can have. I can have 96 core CPU server with 768 GB of RAM. Okay, I can also have a graphics card, right? So let's continue tomorrow. I think we are out of time. We are going to continue tomorrow from here, right? Okay, friends. Thank you. Thank you so much.
Thank you.
Thank you.